Hey, how are you doing? So today we're going to solve question number 27, remove elements. We're going to first read the question. I'm going to show you the thought process and how we solve it. And then finally, we're going to code some of the solutions. Okay? Stay tuned. All right, let's read the question. Remove elements is the question we have. Given an array of nums and a value, remove all instances of that value in place and return the new length. Okay, cool. So in here, we have to make sure we're given an array and we're given a number, right? And we have to remove all the instances from that array in place. That's why they highlighted it in place. And return a new length. Okay, so we have to do two things. One, remove the instances, and two, return basically the new length of this new array. So these are the two things we need to do. Okay, do not allocate extra space for any other array. You must do this by modifying the input array in place with O of 1 constant extra memory. All right, so you can't go and create like a big storage of n size. You have to use something that is very predictable. Okay, that seems pretty simple. The order of the elements can be changed. That's kind of a hinter. It doesn't matter what you leave beyond the new length. Okay, that's a really big hint too. Like, why would they? Sometimes when you read these questions, you have to ask yourself, like, why do they even bother giving me these extra tips, right? Or if you're going through the interview, why do they even bother to tell me like these little extra side hints? Now, you can only run into one of two cases, right? One case is the interviewer can be like really, a punk and just like throw you off because he's having a really terrible day. Or with the benefit of the doubt, they're trying to give you a hint to solve the problem, right? So when we're looking at this problem, before we code, we have to ask ourselves, okay, what's the problem really asking, right? So you're given an array size, you give a number, and you just have to remove those elements and give that size of that new array, right? If we didn't have the limitation of constant space of this O and 1 extra space, memory space, this sounds like a very simple question, right? Just create an array, iterate through it, and push the ones that are not equal to the value that you're given, right, into that new array, right? That seems simple enough, but the key thing is we cannot use that extra space, right? So what can we do to solve this problem, right? So when I'm thinking about, okay, what do I need to do if I don't know how to solve this? So I know I need to go through every single number, right? So at the very least, my time complexity needs to be O of n time, because I need to go through every single number to check whether or not it is equal to the value, right? So we need to know that. So it's gonna have a for loop in there, right? The second thing we have to think about is like, okay, well, as I check through the numbers, right, I need to do something, right? But I don't know what that something is yet. But in our case, we have to find a way to either A, delete it, or B, move it around, right? Because it says here that you could change it where the elements can be changed, right? As a tip. So with that in mind, I feel like that there are some really nice JavaScript things that we could use. Something that really pops into my mind right now is like, okay, some native high order functions are going to be like something like splice, as I iterate through the array. If I see the number equal to the number that's given to me, I could just, splice that value out. And to use splice, for those who don't know, you just give the index and how many items you want to splice out. And then that effectively manipulates the input, right? You could do that. And that would work. But let's see if we could think about other ways to solve it, because there has been cases where interviewers don't like you to use high order functions, right? They want you to almost, reinvent the wheel effectively, right? So how can you achieve similar things but without using these high order functions, right? If you think about it, all right, so we know that we are given X amount of space, right? But X amount of space is meaning it's the input array's memory space. So if we look at the example here, right, you're given a memory space of 4, right? It was an array size of 4 with 3, 2, 2, 3, and a value of 3, right? So what do you have to do in this case? When we eyeball it, we know that, okay, we need to remove the tail and the front, but keep the 2 here, right? Simple enough, and then return the 2, right? But what can we use here that can help benefit us, right? That we can't, if we don't want to use splice. This is our solution. So let's think about it. Okay, well, what are the data structures we can use that is, all of one space, right? We can always just create a variable, and make sure that that variable is of size, something to store, right? So we could go like, okay, maybe we could think about, okay, what's available to us? I think we could probably think about, well, I could use a variable to store this artificial, like a pointer in a sense, right? If you think about it, if you have a pointer, right, pointing at the index, like say I want to start with a pointer at position 0, right? What I could do is, well, as I iterate through the input array, I can see if that value does not equal to the value I'm interested in. And if that's the case, then why don't I just, put that value where it belongs, which is at my pointer's reference, right? And then increment my pointer to the next item, right? So what I mean by that is that, okay, well, if you set your pointer to, say, for example, 0, right? And you start iterating through your array at 0, right? And assuming this 3 was a 1 or something like that, what's gonna happen here, right? All really happens is gonna be your 0, start from 0, you're pointing at 0, right? And you iterate, you're gonna check, is my 1 equal to 3? No? All right, well, I'm just gonna make that number, that space at my pointer position equal to where I'm at right now, right? I can go iterate through, but if it equals to the same, I might skip it, right? By skipping it, you effectively, eliminate it, right? So let's dive into some code and see where we can solve this. All right, function. I'm gonna go and remove this just to make things a little bit more clean. So I'm gonna start the first approach that we're talking about earlier. One of the things we need to sometimes check, or if you go to the interviewer, you want to ask them, hey, are there any edge cases? Like, am I gonna be given gibberish? If they don't tell you anything, in this case, it doesn't tell me anything, I'm gonna assume that they're gonna give me gibberish. So I'm gonna check if my nums array is true or not. If it's not true, I'm gonna return a 0, right? So those are I always like to have the first segments, on top segments, to put in like these edge cases to check. That's always what I like to do. And then what I was mentioning before, we're gonna write a simple for loop for let I equal to 0, right? I is less than my nums dot length, and my I is plus plus. So what we're trying to do here is iterate through every element of that array, right? And check if that number, nums at I, if that number is equal to the value we're looking for, right? If it is, well, what do? Well, the first case we're gonna try is just gonna splice it. Splice at the I and give it a 0. Oh, 1, right? So what you're doing here, what I'm gonna do is basically I'm gonna splice it out, and then I'm also gonna go, okay, reset my position, right? Because I'm gonna go iterate, I go to 3, I'm gonna splice it out, so it's gonna remove this element, right? But I have to make sure that I gotta reset my index back to where I started, right? Because my new array is gonna be like, 2, 2, 3, which position 0 is still here, right? So position 0 will be 2, right? So I have to check that number. So I gotta make sure I have to decrement it. And then at the end, basically this will clean everything and you just return the nums.length, right? And you should pretty much get what you need. So let's submit this and try if it solves anything. Great. So this solves pretty much 99% of everyone, and great space complexity too, right? However, let's try another approach. So we know that this way works, but say you're not allowed to use splice, right? So what can we do here, right? So one thing we could do was mentioning before, well, why don't I create a variable, let, I don't know, pointer equal to 0, right? So this is gonna point into my I guess like a shadow reference. You can think about it that way. And what I'm gonna do this time around is check, and what I'm gonna do here is skip the numbers that are not equal to my value, right? So I'm gonna check here, make sure I skip those numbers, right? But the difference here is I'm gonna be doing this. All right, well, I'm gonna go set my nums at I. Actually, no, my pointer will equal to the value at nums at I, right? And then increment my pointer, right? So in this case, what am I doing? Effectively, I am just incrementing my pointer as I get items that are not equal to the value that I'm looking for, right? So in here, I'm just gonna return my pointer, because the pointer will pretty much tell me the actual length of this new array without deleting anything, right? You know, the first approach, we deleted things. This one, we don't really need to delete things. We're basically shuffling numbers around within the same array. And the pointer will basically indicate how long or how big that item would be, right? So let's see if this solves the problem. And yeah, it does solve it. It's not as great as a splicing one, but at the very least, you can solve this problem. You know that there's two approaches. One is you shuffle numbers around. Two is you actually just delete it in space. And yeah, that's pretty much it. I hope you guys enjoy it. If you like it, this type of video, give me a thumbs up. If you don't, you know, just let me know in the comments on how I can improve. I'm gonna try to continue more now, since we're all in this special situation. But yeah, hope you guys have fun and learn more in LeetCode. See you guys.